Today we're going to look at Little Man Computer, or otherwise known as LMC. It's an assembly language emulator. You need to go to www.peterhigginson.co.uk/LMC to be able to run the programs. For the emulator, it has a few basic commands. It has load, LDA, store, STA, add, ADD, sub, SUB, input, IMP, output, OUT, and halt, HLT. There are some branching conditions, BRZ, BRP, and BRA, and they are branch if 0 is in memory, branch if the number in memory is 0 or a positive number, and branch always, which means no matter what's in memory you are going to branch to another place. The last command we have is a DAT command, and this command is so that you allocate a part of memory for a variable. Using these basic commands, we'll have a go at writing a simple program. Now when you've opened up the page, it will look a little bit like this, and the first thing we're going to do is we're going to type in IMP to get something from the keyboard. As soon as you do IMP, it takes from the keyboard and it stores it in memory. That's only temporary memory. If we want to save it, we have to do a store command. So we could do STA and we could store it as num1, but we must remember to use num1 dat, which means store somewhere in memory so that we can put our variable into that place in memory. These DAT commands always go at the end of the program. Now this would take a number, store it in the memory address num1. Now it's actually still in memory as well, but if we wanted to, we could load it up to be sure, but it would still be in memory. And yes, so we can see some on the screen, we could output it. Now it's always good to halt your program at the end. If I click on submit, it takes this data, puts it across into actual proper code ready to be run, and also that code goes across into RAM. An input command is called 901, a store command, store is 3 and we're storing in position 5, so it's 305. A load command is 5 and it's storing it in 505, and then an output command is 902 and the halt is just 00. You don't need to remember these codes, but you'll see that there is a pattern. And if I was to make a mistake, say I was to type input rather than INP, when I try and submit the program, it won't actually convert it across to code. It will do the first line and it will say, well, hold on a minute, there's a problem, and it will stop. But if you correct that line and click on submit, you'll see it does a piece of code for every line I've typed in, which means it's worked correctly. Run to run our program, and our program will start running. If it's going a little bit too slow, you can click on these arrows here to speed it up a little bit. Now our program has worked itself around to the first command, which is input. And if I input the number 5, press enter, 5 goes in, it's being stored in a place in memory, which is actually, if you look here, we have 5 was a DAT, and it has stored the number 5 in position 5. And yes, it's output the 5 as we asked it to, and then halted the program. Now let's try a slightly different program this time. Our first program has worked. Let's see what else we can do. What we're going to do is we're going to take in a number, such as 6, and we're going to count down 6, 5, 4, 3, 2, 1, 0, like a countdown timer for a rocket launch. So we're going to ask the user for a number, so we can use the input command. Now if they input 6, we're going to do 6, 5, 4, 3, 2, 1. So we need to output that number that's actually in memory. The next thing we need to do, if they've input 6 and we've output 6 to the screen, we want to take 1 off. So we want to subtract 1. Now unfortunately we can't just put the number 1, but what we can do is we could have a variable called ONE, and we can actually have a DAT called ONE and give it the value of 1. So we can subtract 1. If we typed in 6, it would output 6, then 5 is in memory. Now we could just output it, subtract 1, output it, subtract 1, but we don't know how many times to do that. So what we can do is we can loop around, and we want to loop around until we've written out 0, and then we're getting into negative numbers. So what we're going to do is we're going to branch, but only if the number is positive, back up to the top. Now I'm going to just call the top loop. Now it's very important when you are doing these little labels, the label actually is on the line of code. So it's going to be on the same as the output line. Now my program would now input 6, it would just read the label, that's fine, and output 6. subtract 1, so 5 is in memory. It says, is that positive? Yes, it is. So it's going to go back around and output the number 5. Subtract 1 to be 4. Is 4 positive? Yes, output it. Subtract it to 3, output 3. Subtract it to 2, output 2. Subtract to 1, output 1. Subtract 1 to make 0. Branch if positive still loops around for 0 as well as positive numbers. BRP is 0 and positive numbers. So it would loop around and actually output 0. It would subtract 1 to be minus 1. And then it would say, hang on a minute, I don't want to loop anymore. So it would carry on with the rest of the program. Now the last bit of the program, actually, we don't want it to do anything. We just want the program to stop. So we do a halt command. And that's actually all our program needs to do. Now if I just submit this code, it builds it all. I click on run, speed it up a little bit, ready for us to do our input command. So I'll put in 7 perhaps. That's my number, and it should now tick away and do 7, 6, 5, 4, 3, 2, 1, 0, and then halt. And that's our first basic little program. And this involves a branch, it involves a subtraction, and it involves a variable, and it involves an input and an output. So that's all the major things in the programming language. I'll do some more videos later where you can do some slightly more advanced programs.